Bismillahirrahmanirrahim. In this video we will discuss how to design modular multi-level converter using nearest level control modulation. We will design for 11 level single phase MMC at first. So for this we go to the library browser and we go to the power electronics. We are designing this MMC by using half bridge MMC, therefore we pick up this half bridge MMC. Alright, now let's give the values to the parameter. Let us say capacitance value 1 e power 9 and let all the other parameters be the same. We need to give a gate signal, so here I am taking one input, this one for the gate signal. Let's name it G. I need a constant to give it to block state and it should be 0. And I will give this 1 and 2, these output ports, PIM IO ports. Alright. Let's name it 1 and let's name it 3 and let's shift it to the right side. Port location on parent subsystem should be right side, and we are not using M terminal, therefore we pick up a terminator and we connect this terminator here. Let's create a subsystem from here. So this is one submodule. This is one submodule. For 11 level submodule using n+1 conventional NLC, we require 10 such submodules in the upper arm. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Alright. Okay. I need to pick up output let's connect it to this terminal. Sorry. Sorry, this should be PMIO port. Sorry, my mistake. PMIO port towards right. Alright. Port number 2 right. Now let's cascade these all submodules in a chain link. This is called modularity in MMC, that the half bridge submodules are connected and cascaded to get higher levels. Like this 10 submodules will give us 11 levels. If there will be 100 such half bit submodules, we will be able to achieve level of 1 over 1 using conventional MMC. Alright. Okay. So let's give gate signals to these 10 submodules and let us pick from Alright, let's label it G1 to G10. Let's name it G10. Alright, so this upper submodule is now ready. Let's make a subsystem of it. So this is upper arm of single phase MMC. Alright. Let's expand it and name it upper arm. We also need a lower arm. So this is our lower arm. Same submodules will be there. Number of submodules in upper and lower arm will be same, but the gate signals will be different. This will be G11. This will be G12. G13. G14. This will be G15. G16. G17. G18. G19. G20. Alright. Now we need a DC battery, DC source. So we pick up a DC source from here and let's connect it here. We also need another DC source. Alright. We need a ground. So let us connect a ground over here. We need inductors, 2 inductors to be connected between upper and lower arm. So go to the passives, series RLC branch, make it inductive. Its value should be 20 millihenry. let's connect it here this way. Alright, we also need one current measurement. Let's rotate it. This way. We need to connect one load, so series RLC branch, rotate it, make it RL load. Alright, and the load value should be 50 ohm and 10 millihenry. Alright, connect it here this way. We need also a ground. Copy it, rotate, connect it in this way. Alright, we also need one voltage measurement. And then rotate, and then flip it. Flip it. Sorry. Flip up down. Alright, positive should be connected here. Negative should be connected here. Finally, I need scopes to see the output. Alright, so this is the scope to see the current. You can get the scope from library, and this is a scope to see the voltage. Alright, so circuit is ready. DC voltage should be, let us say in this case, 2000. Alright, now let us make its controller nearest level control. Alright, I need a sine wave from the library browser. So this is a sine wave from the library browser. Alright, and I need to take gain block. Make it -1 to invert this sine wave. Therefore, I have added a gain with -1. Alright, then I need to go pick up input. This is the input. Let's name it U reference. Alright, let's get again, and here the value of gain will be equal to whatever the number of half bit submodules are. Half bit submodules are 10, therefore the gain will be 10. I need one add function, add arithmetic operation block, this one. So let's add it, and I will pick up a constant block. sorry. So the here constant value will be same as number of half pitch submodules. Alright, I need a round function. This is a round function. Alright, I need a saturation block. Alright, saturation block upper limit will be the number of submodules, lower limit will be 0. Alright, after then I need a comparator block. The block name is basically relational operator. So I need to pick up a relational operator block. So, alright, so this is a relational operator block. Alright, we need to take a not function. Give the not to here. Then I need a mux. Alright. Alright. So this knot will not be connected here. Sorry, here we will connect a constant block whose values should be a range of value from 1 to 10. Right. Okay. We will connect knot here to get signals. One thing should be taken care here, that this setting should be data type slot double here. This is very important. Here it should be nearest. Alright. Pick up a selector block. Okay. Now selector block will decide how to give the get signal pattern. So if it is 11 level with 10 submodules, the pattern should be 1 and then it should be 11. 1, 11. Pattern should be like this: 1, 11, 2, 12, 3, 13, 4, 14, 5, 15, 6, 16, 7, 17, 8, 18, 9, 19, 10, 20. This should be the switching pattern. Let's check what is the mistake. 1, 11, 2, 12, 3, 13, 4, 14. Okay, here number of ports should be 2 into 10, I mean 20. Alright. Sorry, it should be 10 into 2. It should be 10 into 2. So let's troubleshoot here. It is hang for a little bit time. PC is not working. Let's reopen it. It is named as MMC. Sorry for the inconvenience. This is the model. Let's take the selector again. So this is the selector. This should be the selector, sorry. Okay. Now the setting should be 10 into 2, and here it should be 1, 11, 2, 12, 3, 13, 4, 14, 5, 15, 6, 16, 7, 17, 8, 18, 9, 19, 10, 20. This should be the setting. Alright. Alright. So alright. So after this we need to pick one output. Need to pick one output. All right. Where it gone? It again. Date block to model MMC. That's output. Okay. All right. Let's call it upper arm. All right. This data type should also be. Please make sure this data type should also be float double. Data type should match. So this is the gate signal settings for the upper arm. Similarly, we need gate signal settings for the lower arm. This should be plus and minus. Alright. Constant 10 should be added here, and this negative signal should come from this round portion, and the rest of the setting will be same. Alright. So let's make it lower arm. Alright. So let's create a submodule subsystem from it. Now we need to give this gate signals up to upper and lower arm. So for this we need to pick one input. This input, and we need to pick demux. Sorry, cancel. And there should be 10 gate signals. Expand it. it here, name it for upper signal, gate signals, and now we need to select go to. From library we need go to. PC is hanged, waiting for the PC to respond. Okay, it has responded. So this is go to. You need to make it global and label it for upper arm G1 to G10. So copy it, make it G2, then G3, then G4, then G5, G6, G7, G8, G9, and then G10. All right. So let's make it subsystem, and let's give this gate signals to the upper arm, and similarly we need for the lower arm. Let's name it lower arm. All right, and we need to change these gate signals G11, G12, because for the lower arm gate signals were from 10 to 20, G13, G14, G15, G16, G17, G18, G19, and G20. Alright, so the settings are done. Let's connect it to lower arm. So this is our control portion. Finally, let's make a subsystem of it and name it nearest control level, NLC. So this is our NLC control. Alright, let's run the block and see the results. Okay, we have not taken power GUI, so let's take this power GUI. Alright, now let's run it again. You can take this Power GUI from the library browser. Alright, so now let's see the output. There is some issue in the negative portion. There is some issue in the negative and the negative portion. So let's see where we have made the mistake in the negative portion. Alright. G11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Alright. Okay. Let's check the control. So far the control is 10, 10. Okay, there's a mistake. We have not taken a multiplier of 0.5 here. Again is missing here. So let's give it again. Of 0.5. Alright, this was a missing block. I hope now it should give the results. Alright, perfect. So now we are getting 1, 2, 3, 4, 5 levels, 5 for the positive portion, 5 for the negative portion, 10 and 0 level. It means overall we are getting 11 levels with 10 half-bridge submodules. So this is an 11 level MMC with n plus 1 level conventional NLC. Okay, next portion we will discuss in detail how to design this NLC control portion. What is the function of each block. Okay, thank you very much for listening.